Welcome to solverfy.
So in this problem, we are given with a sample of a liquid which is contained in an unlabeled container and which is thought to contain this propanoic acid, but it is not sure whether it is propanoic acid or not. And we are given some data here, which is when a certain mass of this liquid is combusted, it produces this much of water and this much of carbon dioxide. And from this given data, we have to say whether this unknown liquid is propanoic acid or not. So how can we do that? So we are given here the molecular formula of the propanoic acid. So what we can do is we can find out the empirical formula of the unknown liquid sample from the given mass of water and carbon dioxide which is produced from the combustion of this unknown liquid. And um, from these unknown values you can find out the empirical formula of this unknown sample, and we can compare the empirical formula of that unknown sample with the molecular formula of propanoic acid, and from there we can say whether this unknown liquid is propanoic acid or not. So what we'll do is we will follow some simple steps to find out the empirical formula of the unknown sample. So since we are given the mass of carbon dioxide and water produced from the combustion of this unknown sample, at first we'll find the number of moles of that CO2 and H2O produced. And from the number of moles of CO2 and H2O, we'll find the number of moles of carbon and hydrogen in the CO2 and H2O produced. And from there, we'll find the masses of carbon and hydrogen in the CO2 and H2O produced. And from there, we will be able to find out the mass of carbon, hydrogen, as well as oxygen in the sample of liquid. And then we will convert all the masses into number of moles, and then we will find the simplest whole number ratio of those moles by dividing each number of moles by the smallest value of the number of moles. And from this simplest whole number ratio, we will be able to determine the empirical formula of the unknown sample, and from where we will be able to compare the empirical formula with the molecular formula of propanoic acid, and we will be able to say whether the unknown sample is propanoic acid or not. So let's start with the first step where we are finding out the number of moles of CO2 and H2O. That is very simple. We just divide the mass of CO2 by its molar mass, which is 44.01, which is the molar mass of CO2, and we are given the mass of CO2 as 0.374. And from this we can get the number of moles of CO2. And similarly, we find out the number of moles of H2O by just dividing the mass of H2O by the molar mass of H2O. And now we know the number of moles of H2O and CO2 produced. Now we have to find out the number of moles of C and H in this number of moles of CO2 and H2O. So how we can do that? So in one molecule of CO2, we can see that we have one C. That means in one molecule of CO2, we have one carbon. That means one mole of carbon dioxide will produce one mole of carbon. And similarly, 0.008 mole of carbon dioxide will produce the same number of moles of carbon. And in case of H2O, we can see that one molecule of H2O contains two hydrogen. That means one mole of H2O will produce 2 mole of hydrogen, and that means 0.006 mole of H2O will produce 0.006 times 2 mole of hydrogen. So in this way, we can find out um, the number of moles of carbon in CO2, which is basically the same as the number of moles of CO2. And from this number of moles of C, what we can do is we can um, find out the mass of C in CO2 by simply multiplying this number of moles of C by the molar mass of C, which will give us the mass of C in CO2. And then we can also find out the number of moles of H in H2O as just by simply multiplying the number of moles of H2O by 2. And then from there we can find the mass of H in H2O by simply multiplying this number of moles of H by the molar mass of H, and this will give us the mass of H in H2O. Now, since this CO2 and H2O are being produced from the combustion of the unknown sample, and these are the only products of the combustion, that means this amount of carbon in CO2 is also the mass of carbon in the original sample. And similarly, this mass of hydrogen in H2O is also the mass of hydrogen in the original sample. So we can count these two as the mass of carbon and hydrogen in the original sample. And from here, we can write down that the mass of carbon in the sample is, as we have just calculated the mass of carbon in CO2, and mass of hydrogen in sample is also the mass of hydrogen in H2O. And we are given the mass of the original sample, so we can just subtract the mass of carbon and hydrogen from the original sample mass to get the mass of oxygen. Since in this unknown liquid only we have three components, or we are just assuming that, since we are assuming that this is a propenoic acid, and in propenoic acid we have only carbon, hydrogen and oxygen. That means we can assume that there is no other element in this sample. So we can just assume this whole mass as the sum of carbon, hydrogen and oxygen. And as we know the mass of carbon and hydrogen, we can just subtract this from the whole mass to get the mass of oxygen. Now we know all the masses, we can just convert all these masses to number of moles. We just divide the carbon mass by the molar mass of carbon to get the number of moles of carbon. Then we can divide the number of the mass of hydrogen by the molar mass of hydrogen to get the number of moles of hydrogen. And then we can divide the mass of oxygen by the molar mass of oxygen to get the number of mole of oxygen. And from here we can see that the smallest value is 0.08. Now we will divide each number of moles by this 0.008 to get a simplest whole number ratio of this number of moles. So here is our values after we divide each number of moles by the smallest number of moles, which is 0.08. It will give us values like this. So here we can see that none of these values are just, except the value for carbon, the value for hydrogen and oxygen are not whole number. So if you want to make them the nearest whole number, we have to multiply them by 3. In that case, we'll have to multiply each one by 3. We multiply it by 3 and it will give us approximately 4. And if we multiply this by 3, it will give us approximately 4. And if we multiply the number of moles of carbon ratio by 3, we will get 3. So the simplest ratio here is CHO is 344. That means the empirical formula of this unknown sample will be C3H4O4. Now here we can see that for the propenoic acid, the molecular formula is C3H4O2, whereas our unknown sample has the empirical formula of C3H4O4. That means, as we know that there is a relation between molecular formula and empirical formula, which is if we just place a value of n here, that is, which is a whole number multiple. So a molecular formula is always a nth multiple of its empirical formula. And we can apparently see from here that this empirical formula can never have a molecular formula like this. That means the sample of liquid we have here is not propenoic acid.